Well, I may have gone a little crazy designing some parts. This is all the parts that we've designed and built for the car, all the different cooling upgrades and ideas. I'll walk you through each one of these, the thinking, where we got it right, where we didn't. Again, this is an iterative process, so there's a lot of different versions within each one of these designs. And so I'll take each one, walk you through the thinking, and then we'll start to put this whole thing together. All right, so the first project we're going to tackle is the little door vent. And so the thinking here is, as we design this, I'm going to design a piece that gets as close to here as possible. So it'll have maybe this, follow this arc down so it stays nice and close to the car and then arcs up. And I'll show you a little trick on how you can get this arc. All right, guys, so now the next step is, how do we pick up this arc? And I'm going to show you a real old school way. I've been using this method for 30 years working on cars and other things. When you're trying to pick up a bolt hole pattern or a profile, this works like a charm every time. So you grab yourself a piece of paper, doesn't matter what it is, it could be scrap paper. You do this. You put it over the door or whatever you're trying to get a profile of. You hold it tight, and then you just simply press. And the dirtier it is, the better it is. And what you can kind of see is now you have that profile. And what I can do with a Sharpie marker is I can just go back in and draw over that to pick it up. I can scan this in, and then in our CAD package, I can drop this in and use this as a layer that I'll show you later. And then I can draw lines over that and design whatever I want.
Okay, so now that we've got the door profile in paper, what we've done is we've scanned that in, and now we're going to drop it into CAD, and we're going to build this little test piece. So first thing we'll do is we'll create a plane. We'll go ahead and drop in the actual sketch. So now we have, this was the sketch. So this was when I rubbed my finger against the door profile to get pick up the arc, and I just literally just put in a pen mark on top of it, and then just kind of sketched in what I think it'll be. So we can sketch that in. And now that I've got this as an underlay, that's what it's called in CAD, is an underlay, I can draw on top of it. And CAD's pretty simple. You're just manipulating curves and surfaces. And so I've got this in there. So now let's turn on a profile I built. Let me click on it so you can see it a little bit easier. So we've got these two lines that I've drafted in, and you can manipulate them. So these are, if I wanted to go ahead and edit those in, I can move the lines around, I can edit them, I can add radii on those, but for now, let's just say that this is a good profile, good enough for us to test. So I've got that in. Rotate this around. Let's turn off that sketch so we can see just the curves. In fact, let's turn off the plane itself. So now we just have these curves, and what we'll do is we'll extrude a shape from that, a little test shape. So it's pretty simple. We'll just grab the curves, and we'll do a little extrusion. So what's cool about CAD, you could just grab and drag, or you can give it an exact number. In this case, we'll say it's going to be 2 inches. And while we're at it, let's make this hollow. And maybe about 100 thousandths wall. That'll be good just to test. And let's OK that. So now we've turned this into a 3-dimensional part, a solid, that we can export out and drop into our 3D printer. I can manipulate this further if I really wanted to. For instance, I wanted to go in here and add some edge blends or some fillets. We can add some here. We can add some on the inside if we wanted to. There's all sorts of things, but you get the point. Is you can manipulate this and do as much or as little as you want. For us, we're just going to leave it as a simple part because all I'm trying to test out is the arc correct? Is this opening just about right? And then can I manipulate it? If that works good, then I'll build a part with a little path, essentially, where I'll draw a line up. It'll go up and over and into the car, and I can take this curve that we used originally and extrude it out on that path, and then we'll have a finished part.
All right, so we've taken that scanned in arc into CAD, and I've drafted a little piece, a little test piece. This isn't the full vent, but I just want to test and see if we got the arc right and if we think that directionally this will work. So what we came up with is a little piece that looks like this. So it's just a little test print, and I'll show you the printer that we use. It's a little 3D printer we have here at the house. But what it is it's just, that's what the vent's going to look like. And so this profile will rest right up against the door, and that profile is almost dead on. So you can kind of see that. This then, I'll extend this out and it'll run up and into the car. And so let's go inside and design that up, and then we'll see how that fits. All right, so after a few hours on the computer and then printing out these parts, this is kind of what we've got. So we started off with that little piece that we took our finger and got the profile. I drew a Sharpie marker on that line. I scanned this into the computer. And then in CAD, I basically drafted up this profile to fit. So this matches up that profile that we just saw in the car. Then I took this and used it as an extrusion. And so what this is going to look like is this little piece. And I've run these 3 separate pieces and glued them together, and I'll epoxy this all up to make it strong. A couple of attachment points, sanded down it a little bit. It's not finished, but it's a good test part. So the idea here is it's going to sit on the car like this. Air will come in the door here. It'll run up through here. And then finally that will run right to the driver's hands on the steering wheel. So a cool little part. Not sure how it's going to work. The thinking here too is we'll attach this to the windowsill, that I'll show you here in a second. But again, if it works, great. If it doesn't and we can tweak it, we'll tweak it, or we'll trash it and try something else. All right, so I wanted to show you how the vent print sits on the car. So we have it sitting here right now on the windowsill. So the air will come in here, will come up and around. And as we close the door, you can kind of see, we'll have it aimed. Maybe we'll move it just a little bit this way. It'll be aimed right at the driver's hands. And so I'll show you how we're going to attach this to the door here in a second. All right, so I think the way that this is going to attach, it's going to be pretty simple. What I've done is designed in these 2 little ribs. The ribs have a hole, a through hole that goes through both of them. And what we're going to do is we're going to drill onto this little sill right here, a little hole, 1/4-inch hole, and I'm going to use what's known as a Rivnut. And so this is a little threaded insert, it's a special tool. You put it in the hole, and then the tool attaches it, and you've got a female 1/4-inch 20 thread that you can attach things through. And so we'll put a bolt through both of those holes into that Rivnut, and that thing should keep it pretty well attached to the door, and it's worth a try, and we'll see if it works. All right, so let's talk about helmet cooling. So the idea here, as we talked about before, is the hose right now just attaches. It's a friction fit here, and it's really hard to get this on sometimes when you're in the car, you have your gloves on, and you're kind of fiddling with it. So the idea here is, can we permanently attach something here, and then on the hose end and the end here, make it magnetic and have it snap in. Now there's some companies out there already doing that, which gave us the idea. We said, how can we improve on that? So again, this is iterative. And what we did was we started off with this little piece. So the idea here is this guy would slide on. You would have some bolts that would come down, and we'd have another piece that would either glue on this one, or we would mold all this on one. And then on the end, you would have the little magnets put on, and this piece would be on here as well. So then we decided, okay, let's take that a step further. Let's mold it all together, and then we'll see how well this works. So this is what we came up with. This was kind of version 1. So you've got some little nuts that are inside here, little nylock nuts. The air would come in here, come through and on. And so this would go onto this little barbed piece. Problem with that is this guy sticks out quite far now. And when you get in and out of the car, what we noticed when we tested this is this can get hung up on the roll cage. And so obviously we have to think of another way of doing it, but what we liked was, and what this proved, is that this little magnet idea works. So this is on this side, this little piece with magnets, so this is north magnets, south magnets, this actually goes to the new hose. So imagine the hose coming in, this is on the other end, this is attached to the helmet, and then when they come together, you can hear it, and it holds it in place. And all you have to do is clock it a little bit, and it pops out. And this actually worked great, just we had to work on this little piece. So that was the next iteration. All right, so the next version of the helmet cooling improvements was we had the little piece that came out here, but we knew it kind of got hung up on the roll cage. So Alec and I brainstormed a lot and then finally figured out, hey, what we really just need is we just need this end piece. So what we did is we took a piece of the new hose. So this is the new flexible hose that will replace the white hose. And what if we just have this attached to the helmet itself? And now this is free to move around. So if it gets hit on the roll cage, it won't hang it up. And then on the other side, we would have a little piece that looks like this. So this replaces the little L piece. This will slide in and get glued onto this end. And so now this is free to move around. And the cool part about this is we're going to add more magnets, because we also saw that it wasn't quite 100% strong as we wanted. And so we've got more magnets. This one goes to 11. And on the other side, so this is where the hose comes in, Alec had a great idea. He said, why don't we just have these little keyways? So as we're fiddling with it, all we have to do is just kind of get it close, and it'll just find home. So all we're doing is we're just literally rotating it, and it finds home. And when those magnets line up, this thing is not coming apart. And then when we need to take it apart, all you have to do is grab, push a little bit, and this little wedge on wedge idea, we'll just push it out a little bit, and they'll come out.
Okay, so now that we've got the little part designed in CAD, we've exported it into STL file format, which is a 3D printing file format. I've dropped it into a program called a slicer, and what this is going to do is this will slice the part up virtually into layers that then will be turned into a tool path, so that the machine knows exactly how to extrude the material out to build this part out. So I'm just dropping it into space, orienting it on the build bed to make sure it's going to run right. These cylindrical parts tend to work better this way. Hit the slice button, and now this is going to calculate all of the tool paths throughout the whole part. It gives me how long it's going to run, about 3 hours, about 13 grams of material. And then I can preview it and actually scroll through each layer, each build layer, which is super cool. I can make sure it's going to run right, there's no errors. This part actually looks pretty clean as I go through it. So this looks good. So as I look at this part now, this is ready to export out. And I'll export it out into what's called G-code, which is basically a machining language that the 3D printer then uses to go and extrude this part out. So I'll go ahead and export this out, and then we'll get printing and we'll take a look and see how this looks.
All right, let's talk about the prototypes themselves. I'll walk you through and I'll show you a little time lapse of some of these parts being built. But basically, this is PETG material. It's called FDM, is the actual 3D printing technology. And it basically just prints layers all the way up until you have your final part. The interesting thing about this is that sometimes when you have these little overhangs, and it's kind of hard to see, but this little step in here, what happens is the printer actually prints out into space. So you have to kind of clip these off and clean them up. Really all you do is when these come off the machine, sometimes you'll have a little sharp edge, a little flash. So you sand these off, take these little pieces off. You see them on both pieces had this. Clean them up, and then they're good to go. You really don't have to do much. What we're gonna do just to have a little extra safety factor is we're gonna take all of the parts that we printed, all those black parts that you saw, we're actually going to coat those with a 2-part epoxy that we use when we do some carbon fiber work. And that will just keep these layers together a little bit more, especially when this gets really hot in the car. You don't obviously want this coming apart. So we'll clean these all up and then they'll be ready to go on the car for testing.
All right, so now we're going to jump into CAD. I use SolidWorks, great program, been using it for a long time. And we're going to build out this little PVC adapter for the thermos. And so essentially CAD it's a manipulation of curves, surfaces, solids. And so what I'd start to do is I just start to build out and rough out what this product's going to look like, this little part. We'll start with a little circle. I can change the diameter of that at any time. So I just kind of rough it in based off of some measurements, drop it onto a plane. And I know I'm going to want to extrude this out and make a 90-degree bend, and then maybe put a flange at the end. And so we'll just kind of work through it. It's iterative. Some of this, I've got some measurements I've taken, but a lot of this is just kind of designing on the fly, double checking the part and the dimensions on the car. And CAD's great. You can just edit any entity in CAD that's needed. So I'm just starting to lay in some lines here, just roughing this in. I can define those here in a second, change those anytime. And so what I'm designing here is this 90-degree turn, because I'm going to want this part to eventually allow air to go from the inlet hose into this adapter, make a 90-degree turn into the thermos itself, into the little cooler, and then back out. I'm going to make 2 of these, one for the inlet, one for the exhaust. So just dropping in some radius here for a nice smooth bend. Again, I can change this at any time. And even if I print this out and I don't like it or I see something that could be improved, I'll just go back into this CAD model, save it off, do the editing, and then print out a new part. That's the beauty of CAD and 3D printers. So now I'm just extruding out a pipe. So this is a virtual solid, as it were. I'll go in here and I'll add some wall thickness to it so it's hollow. But this actually looks pretty good. It's a really tight bend, which is what I want, because we're a little short on space, so it's a little tight in the car. So I'll go in here and I'll add a little bit of wall thickness. I'm thinking through how the hoses are going to mount, how this is going to actually mount to the little PVC adapter, a little PVC part that I've got on the car. So now I'm going to drop in, this will be the little flange that'll attach to the little white PVC part that's on the cooler. Again, just kind of throwing in some dimensions. I'll extrude this out here in a second, and then I'll make that hollow as well, and then the whole part will get hollowed, which you'll see here in a second. So getting that, now I'm going to extrude it back a little bit. Reverse the direction here. I like what I see. Yep, that's about 1/2 inch. That's from the measurements I took earlier on the car about how much room I have. Maybe I can go a little bit deeper, so we'll try this. If not, I can always redesign it and print a new one. So I like that. And now I've got a little L bend with a little flange on it, and now it's time to make it hollow. So then I can go in here, and it's called a shell command, or just makes it hollow. So I've got a tube that's open on both ends. And now, as you can see, tube is just about ready to go. It looks good enough. I can manipulate it further if I want. I may go in here and add a little radii, because these are little stress riser areas, these sharp corners. So I go in here and add a little radius just to give it a little bit of strength in the corner. Probably not needed, but while I'm at it, it's free. And so I might as well go in here and just add a little bit to take that stress off of that, especially if that hose gets pulled on a little bit. I don't want it obviously to break in that corner. So I can, again, manipulate those radii to come in. Part looks pretty good to me. Good enough for a first print. And then we can take a look at it, put it on the car, see if it works. If it does, great. It's a finished part. If not, I'll come back in, tweak the CAD, reprint it, and we'll go back for version 2. But let's go ahead and print this out and see how it works. All right, so now we're back in the slicer program that we saw earlier with the little hose magnetic end piece that I walked you through. This is the little pipe that we just looked at, the little PVC adapter. So I've dropped it in. I'm going to orient it as well. This one's a little tricky because we've got this huge overhang, and the way printers work, that may be tough. And so what we may actually find is that this doesn't print very well, and there's a technique we can use to resolve that. But for now, I'm going to move this around, get this oriented where I want. I may flip this over so it runs with the flange piece down. I'll have to kind of see, just based on experience, what'll run best in here. I'm going to take a look at this. This is now on the bed. This actually looks pretty good. I may rotate it around so I can see it. So I'm going to film this. I think I'm going to do a time lapse so y'all can see how these things build up. I want to make sure this is facing the right way, facing the camera. I decided to flip this over so it'll run with the flange side down. The little red indicators is the computer saying, hey, there may be an issue here. The way this builds, you'll see it, this may, what we call spaghetti on us. This may get halfway through the build and I have to stop it. Or it gets all the way through and the part looks a little funky. But we'll see here when we run the part here in a minute. So now I'm just orienting it closer to the camera. So this is more for filming than anything. I'm slicing the part back up so I can see what the tool path looks like. And I'll bet you I'll see that this overhang is kind of hanging out in space, and it's probably a high probability it's going to spaghetti. Looks like 7 hours or so to run this. We'll take a look at it here in a minute. We'll slice through it. We'll do the same preview where we can see how this thing's going to build layer by layer. So as it comes up, it'll build. That all looks pretty good. Yeah, right there. As it kind of extends out on the 90, I think that's going to be a problem. But again, this is all iterative. It's all experimental. You know, I can hit the play button and just on the printer and just take a look at it as it's building. I can stop at any time, but it's worth a print. It's only going to print 33 grams worth of material, which in the big scheme of things is not a lot. Here you could actually see the little lines. So each one of those lines is a build. And then in the middle, instead of it building solid, it builds this little hollow support structure to run faster and use less material. Super cool technology. I've been doing design for 30 years, and this technology was space age 30 years ago, and now I've got a machine in my office, which is pretty amazing. But yeah, it looks like that little 90 degree right there is going to be an issue, but you know what? It's worth a try. I could always just rerun this part if needed, but looks good enough. I think I'm going to go ahead and save this off. Yeah, so from our last video, the more I thought about it, the more I thought, well, let's just do another version of this with some supports. And so it's the same exact part oriented the same way, and I've added some supports in the machine. It's literally a button click away to add these little supports. It's a little bit of a safety factor. It'll run a lot longer. So this is running almost 13 hours compared to 7. But it looks a lot more stable because this material right here, as it builds up, will then support right there, right where it turns 90. And rather than have this kind of build out into space and spaghetti on us, we will have some support there. So I'm going to go ahead and just run this one as well, and we'll do time lapse on both of them with and without supports, and we'll see how these parts look.
All right, so we're back at the healing bench, and I wanted to walk through a couple of interesting things we saw as we printed out these little adapter pieces that I just showed you on the car. And the time lapse was really cool, and it actually showed what we're seeing here. So this was the first one we printed out. And as the machine printed out, what you saw here is this overhang was out in space, and there was no support underneath here. So the printer actually printed these little guys in space. It was just kind of extruding it out into space till it got a little higher, and then it picked it up, and then it printed fine. Sometimes these parts will fail, and it'll make what we call spaghetti, where it'll print up to here, you come back, and you just got a big ball of this print, and you got to start all over. And so what we decided to do is there's a setting in the slicing software where you can actually put supports under here and build it, these overhangs as well. So this was version 2. It's the exact same part, but now we have all these cool supports, and you can kind of see how it prints. What we do is then we'll just grab a piece of, pliers, and we'll grab a piece of this, and it'll just pop right off, and then it's a totally usable part. And what you see here is it's none of this spaghetti underneath here. It actually printed solid. The downside of this is it used a little bit more material, and this build was almost 2 times as long as this build, but the part's actually nicer. So in the future, if I have to build another one of these, I'll go this route. All right, guys, I just wanted to show you really quickly. We talked about this little adapter piece here, how easy it is to get this little support material off. So you can just grab it with a pair of pliers. Sometimes you can kind of manhandle it, and it just pops right off. And so we'll go and clean up the inside of the part. But you can kind of see the way that it built. It's kind of this funky lattice, and it just built right on top of it, and it supports it. Now there's none of this spaghetti. I can clean this up with a little sandpaper if I want. Next step is I'm going to grab these with the pliers and just pull all this up, clean it up, and then this part will be ready to go. All right, guys, we're back. We just walked you through the area that we wanted to improve from the blower end. We had that little piece that was on there. It was okay, but it was kind of a makeshift adapter. It was a little janky. So we wanted to have something that was a lot more smooth coming in, and just to have a little bit better airflow. So we designed and printed this piece. It's a little 3" to 1.25". It's very simple. Blower's here, comes to this little hose piece. This will attach onto the adapter. And then on the other end, we will have this new hose from Moorhead Racing. By the way, these guys are awesome to deal with, Moorhead. It's not sponsored or anything, but awesome customer service. And honestly, Their package tracking email system is the best in our industry. So go check them out. Fairly inexpensive hose, but it's nice and flexible, nice and durable. And this will attach here, and then a longer length will come down and into our cooler that I'll show you here in a little bit. Okay, so now let's talk about the dry ice cooling idea that we had. So I spent a number of hours on the computer, on CAD, designing up a number of these parts and printed them out. I want to walk you through what we're thinking here. And then the next steps, you'll see us gluing some of these together and then seeing if this actually works. So let's start off with kind of the core of it all. So this, you may recognize from Homeless Despot, is a little PVC pipe. And what this is a little T intersection. And what the thinking here is, what if we start with this, because we need something really solid. And we have the air coming in from the two vent hoses that we talked about. We build a little container here, which I'll show you, that you put the dry ice in. And then as the air flows through here, kind of Venturi effect, we're going from a big to a small, that air will speed up and hopefully pull in air from the top, all that cool air where the dry ice is. And then it'll push it out and push it up and into the driver area, which I'll show you that idea here in a minute. All right, just wanted to show you guys just really quickly. Sometimes it's easier, especially in CAD, you can draw just about anything. But when you're printing these parts out, sometimes it's easier just to print them out as separate pieces and glue them together. So in CAD, this little plenum, so this was on the back side of our dry ice contraption. In CAD, it's actually one solid piece like this. But when I go to print it out, this is a very long print. This is almost 2 days worth of printing. And if it screws up on any here, I got to start all over. And it was a little bit flaky when I kind of ran the program. So what I decided to do is draw it in CAD, split it down the middle into 2 pieces. And now what I'm going to do is I'm just going to go ahead, sand up these edges to give it a little bit of roughness. And I'm just going to super glue these together, and then we'll have one solid piece that will be super skookum. All right, guys, we're back. So let's walk through all the parts that I printed out, how they all will fit together. We haven't tested this even on the car yet, but wanted to kind of walk you through the thinking. So it all starts with this big heavy-duty bracket. So the roll bar will go through here. We'll bolt it together with 4 bolts. As this is sitting on the car, because we want this to be really skookum, then we take our PVC pipe, we put this little piece on the top that has the dry ice in it. We printed out this little piece. So this will all kind of sit in here like this. So from a side view, it's kind of looking like that. And the thinking here is, we printed these guys out. These will slide over the backside. And you have the 2 hoses feeding here. Air comes in. And because of Bernoulli effect, we're going from a big to a small. So that air is going to speed up. And as it speeds up, hopefully it draws air from where all the dry ice is, pushes it out. And then if this is the driver's seat, the air comes in here, splits out. And we printed these little 90-degree turns that we'll glue on here. That air will come up, come back out. And then from here, we're going to have a piece of hose that comes up and around and onto the harness that I'll show you here in a second. Hey guys, we're back. So I want to now show you all of the parts that we've designed, printed, coated each one of them with some epoxy resin, some 2-part epoxy resin that we use on our carbon fiber parts. And we've got them all installed in the car. So I just wanted to walk you through this. All right, let's start with the blower. So the first thing that we did was this 3-inch into 1.25 inches. Much better. Got rid of all that white hose spaghetti. Did the 2 little 90-degree turns that you can see right there at the bottom. So that goes in. And then the outlet, we did another 90-degree bend. And we've got that attached to this new cooling hose with a magnetic end. Ooh, that Alec will demonstrate here in a minute. All right, so let's take a look at how this actually attaches to the helmet. So this is our little flexi hose, our little 1.25" hose. So now this thing can move all over the place. And if it touches the roll bars we're getting out, it just kind of flexes out of the way. Got these little keyways in 4 places to help it key in, and lots of magnets. So Alec will then demo this for us. All right, so Alec is going to demonstrate the little magnetic attachment. The next project, again, clearly in the ambitious but potentially rubbish territory, is our dry ice cooling. We've got 2 hoses coming in. We've got a 2-in-1 connector. Goes into a plenum. You can take this lid off and add in dry ice. And then comes out, splits 2 ways, and then I'll show you how it connects to the harness. Pretty cool. All right, so now we're over on the driver's side. So those 2 hoses that split come here, and we've got them attached to the top of our harness. So the theory is the air comes down, and then it blows out on both sides, right up against our neck to see if we can get cooled down. Again, we'll test this here in about a month at our first race, and we'll see if this even works. All right, let's take a look and see how these harness hoses route. So they come through the back of the seat. They're attached to the harness. Air comes in, hits the end, it makes a hard 90 and blows right up against our neck, and hopefully cools down our jugular, which then obviously cools down us. And the last thing I want to show you is how this door vent aligns with the driver's hands, and hopefully this provides a little extra cooling. We don't have to take our hands off the wheel to put them out the window, and we'll find that out, see how well that works here in a month as well.